systems in the body. And so we're going to start with digestion. And remember that we did talk about tissues. And the digestive system is composed of organs that have different types of tissues in them. So like, for example, the stomach has epithelial tissue lining it, excuse me, but it also has smooth muscle, which allows the stomach to contract. So when your stomach growls, for example, that is due to the contraction of the stomach when your stomach is empty. And then it's also got a whole nervous system, which actually regulates the secretion of digestive juices. And what's the other? Connective tissue. So the connective tissue helps to support the organ. And when we look at we're going to do a dissection of the rat next week in lab, we'll see that all the digestive organs are actually in a connective tissue structure, which is referred to as mesenteries. Okay. So I have another assignment, and this is actually not due not next Monday, but the following Monday. And so this is an assignment that is related to the digestive system, and it's worth 20 points. And so it's really important that you do these assignments because they will help your grade. Okay? And so you want to try not to forget about them. So you could go ahead and do it right away, but if you could wait and hold on to it, keep it in your notes, right? So that you can turn them all in together. And I'm not going to be like scrutinizing your digestive habits. So you want to be as honest as possible about the things that you eat. So this is related to a governmental website that allows you, it's free, and it allows you to track not only your food, but also your fitness. So it's just a free governmental website because obviously it behooves society in general to have healthy people that can be productive and can work and can pay taxes, right? If we're all on disability because we all have diabetes and we all have lots of medical issues, then as a society, it's not going to be a good thing. Okay? So I also have another handout which relates to the digestive system. And I believe I already gave you one of these images, but I'm just going to give it to you again. And you could just keep one of the images blank and you could quiz yourself. Because this image is going to be on the final exam. You can pass that down to my guy. And then we also have the comparison with the digestive system of a ruminant, specifically a cow. I have your lab notebook, but you have to use the lab so you can go back to this lab is really. So if you want to come down and grab it after class. Or Monday. We have lab on Monday. Okay, so let's talk about the digestive system. And we've already kind of talked about digestion a little bit because we were talking about the incomplete digestive system of a planarian and a jellyfish, for example. And then the complete digestive system of like an earthworm or an arthropod, like a crayfish. And so we talked about incomplete versus complete digestive systems. So one thing that's nice about the complete digestive system, which has a mouth and an anus, is that there's one-way flow of food through the system. So when we talk about a jellyfish or a sea anemone, they take in food through an opening, they digest it, and then they spit out the digestive waste, right? So if we have one-way flow, then we can have compartmentalization. So I'll put that this allows for compartmentalization so that we have now specialized structures that are capable of doing different things. So we have compartments. That looks like a big word. Yes, it is. Is that right? Looks funny up there. Okay, anyway. So when we talk about digestion, there's also two categories. So we have mechanical digestion. So mechanical digestion is just breaking the food up into small pieces. So it would be like chewing, but also mechanical digestion can also take place in the stomach when the stomach churns and mixes. And then it can also take place in the small intestine, and we'll talk about the role of bile that it has in mechanical digestion. So mechanical means that it breaks food down into small pieces. That's pieces. And the reason that this is a good thing is that this actually increases the surface area over which enzymes can act. Right? So enzymes are chemicals that actually bind to food as substrate, and then they break chemical bonds. And they can break down complex carbohydrates, for example, like starch. They can break them down into simple carbohydrates like glucose. Right? And so that is what chemical digestion involves. So chemical is the use of an enzyme, we'll say, to break bonds, chemical bonds, in organic molecules. So both mechanical and chemical digestion occur in our oral cavity in your mouth, right? So in the mouth, remember that we talked about the fact that we have specialized dentition that allows us to be more efficient at mechanically digesting our food. And does anybody remember what that specialized dentition is called? It has to do with being dont. So is it homodont or heterodont? Anybody remember? Think about dont is tooth. If it's homo, that means they're all the same. So what kind of dentition do we have? Heterodont, okay? So we have heterodont dentition. Right? So for example, if you were to eat a piece of beef jerky, you probably wouldn't bite it with your incisors, which are the front teeth, because it would be very hard to get through there, right? So you probably would put it on the side where your canines are, because that is what is used for ripping, right? Likewise, if you were going to bite into a carrot, sometimes you would use that because the incisors, because that's clipping, but then you would grind them using your molars, right? And if the food is not broken down, sometimes it doesn't get digested, right? So I've had students ask me like, well, why are there pieces of corn or peanuts in my feces, right? In your poop. And the reason is that you did not chew your food, right? And so then it just comes out and you do not digest it, right? So that's heterodont dentition. Okay, so we also have chemical digestion. And so we have what is referred to as salivary amylase. So anytime you see that ACE ending, that means that it is an enzyme. However, we're going to talk about some enzymes that do not have the ACE ending. So for example, in your stomach, you have an enzyme called pepsin. That is an enzyme, even though it doesn't have the ACE. But if you see the ACE, then you know that that is an enzyme. So salivary amylase breaks down starch into smaller molecules. So starch can be broken down into your mouth into what is called maltose. And this is actually a sugar that is composed of 2 glucose molecules. So starch is not sweet. So if you've ever eaten a raw potato, that is starch. But when you break it down, it will start to taste sweet. And so you can experiment with this. You can have crackers, for example, that are not sweet. You put them in your mouth, and after a while, even if you do not chew them, the amylase will start to break it down into maltose, and then this is sweet. Right? So that would be an example of chemical digestion. So chewing is mechanical. And if you chew a piece of bread, it's going to taste sweeter quicker than if you don't chew it. And then this would be an example of chemical digestion. Okay. So we're going to talk about the different parts of the digestive system. Oops, we already talked about incomplete versus complete digestive system. So we're going to specialize and we're going to look at the human digestive system, but then we're going to, at the very end, talk about the difference between herbivores and carnivores, and also the difference between organisms that are considered to be ruminants. So when we look at the human digestive system, we have the oral cavity, which is also called the mouth, right? And I mentioned before that in mammals, this is separated from our nasal cavity. So we can chew and breathe at the same time. So we have the sensation of taste because we have taste buds on our tongue. And taste is a very simple sensation. So it's not as complex as smell, but we can taste sweet. We can taste sour. We can taste bitter, we can taste salty, and then there's one more that they have added, which is umami. Okay. So sweet gives us information about energy. So if you haven't eaten in a while and you're running low on glucose, like you've used all the glucose that's been stored up in your liver and in your muscles, you might crave something sweet, right? Because something sweet means that it's going to have glucose, and glucose is used to produce energy. Okay, our brain runs entirely on glucose. What do you think sour? What kind of information does sour give you about your food? That's a tricky one. So oranges and lemons tend to be sour, and they are also acidic. And so this is pH, right? So something sour has generally a low pH, which means that it is acidic, right? So this means that it is acidic. But we have an essential nutrient that is also acidic, and sometimes you'll crave it. And what do you think is a nutrient that you have to have? And if you don't have it, you will get a disease that is called scurvy. Vitamin C, somebody said it. And I read an interesting thing about, they were writing this up in, I don't know if it was a medical journal, but somebody actually had scurvy because for some reason they just did not eat any fruits. And so they were actually depleted in vitamin C. And one of the things that vitamin C causes is bruising, easy bruising, and then wounds that won't heal. And so even today, people can become malnourished if they do not have vitamin C, okay? Bitter is an interesting one because it generally means toxin. So plants actually produce toxins that are bitter. So when you taste a bitter plant, there might be toxins in it, but there also probably are good nutrients also. So like kale, for example, might taste bitter to some people. Caffeine, which is in the coffee bean, is also bitter. And then dark chocolate is also bitter. So sometimes bitter can be a learned craving, right? So we like our coffee really bitter, but we shouldn't like it bitter. But we like it because we've learned that bitter coffee, gives us quote unquote energy. Not really, but it makes us feel like we have energy. And so we're more awake and active, right? And so we can learn to like bitter, but in general, children do not like bitter. And so sometimes it's really hard to get them to eat vegetables because they are sensitive to the bitter taste of them. And interestingly, pregnant females early on, what you'll find is that during the period of time when you have morning sickness, you might really be turned off by coffee or anything that's bitter, but also by vegetables. And so it might be that you just want to eat saltine crackers, for example. And that doesn't give you a lot of nutrients, but it also protects you against ingesting toxins that might actually do harm to the developing embryo. Okay. So there's a thought about why during early pregnancy, people get aversions to certain types of food. So what is salty? What is the mineral that we're getting from salt? Actually, two minerals. Does anybody know? Some animals actually eat dirt in order to get minerals. So sometimes you might see deer and they go to this one spot of dirt and they might get their hooves down there and they might actually eat the dirt in order to get essential minerals. So what is your table salt composed of? If you take too much of it, what are you getting an excess of? Sodium, right? So this is sodium. And this is one of the things that your food tracker will say, oh, you have too much sodium, right? Because we've added a lot of salt to our food, which makes it good because we kind of crave that. But in excess is bad because it actually leads to high blood pressure. So you see grandma and grandpa have a low sodium diet. The thing about salt, which is really weird, is that if you go on a low sodium diet, so if you stop eating so much sodium and then you eat something that you used to eat, you'll be like, wow, this is really salty. Because you kind of build up a resistance to it and you don't sense how much salt you're taking in. So if you reduce your sodium and then eat something that you normally would eat, then you might be surprised at how salty it would taste. Okay, so umami is savory. And it is designed to mimic protein. So let's say that you're craving protein and so you go for ramen. What is it in ramen that tricks you into thinking that ramen has any protein in it? Because it doesn't. I'm trying to convince my children of this, right? So they come home and they eat ramen, they feel all nice and good about it, and it doesn't have much nutrients at all. What is the chemical that they add to fake you into thinking that you're getting protein? MSG, right? So that is an additive. So you don't need to know that, but MSG stands for monosodium glutamate. And it tricks people into thinking that what they're having is high in protein, but you don't get protein, so then you crave more of it. So like MSG and Doritos, you can eat a whole bag of Doritos, right? And you're like, I'm still craving something. It's like, your body's probably craving protein, it's craving savory, and what you've given it is carbohydrates and salt and MSG, and it's just kind of confused, right? Okay, so that's the taste aspect of this, okay, the oral cavity. So it gives us ideas about our the nutrients that are in our food. We also have the salivary glands. So if you look on the assignment that I gave you, or not the assignment, the diagram that I gave you, Those glands are located here in the cheek, under the tongue, and actually underneath the jaw. So those are the types of glands that actually have ducts. And so those are called exocrine glands because they're not producing hormones. So this is exocrine. Right? So we have water. Oops, we have water. We have enzymes. We also have antibodies. So antibodies are a part of our immune system. So when we take in food, it can have bacteria on it. It can have a fungus on it, right? And hopefully those antibodies would be able to fight off those. We also have enzymes that break down bacteria, right? So if we were to look at that diagram, right? These all would be examples of salivary glands. And sometimes you can feel them if you run your thumb underneath your lower jaw. Sometimes they get swollen and painful. There are also lymph nodes under there, though, that can also can be swollen when you're sick. And then the ones up in the cheek are the ones that are infected when you get mumps. So mumps is actually a viral infection that causes people's cheeks to swell up like chipmunks storing stuff in them. And so those big salivary glands are in our cheeks. Okay, so this would be the oral cavity. Okay, notice they do not show the nasal cavity there, but there is a bony palate, a hard palate and a soft palate that separate our nasal cavity from our oral cavity. Okay, so if we go back to the oral cavity, we have the tongue. And the tongue is really important for sensing taste, as I mentioned before, but it is also used for manipulating the food. Right? So it manipulates food by like pushing food underneath your teeth. And so if you think about when you're chewing, and if you've ever tried to, like, after you've been to the dentist and your tongue is numb and you're like, I want to chew some food because I'm hungry, right? You're going to bite your tongue, right? Because it's really easy to bite the tongue if it's pushing stuff underneath the teeth and then having to get out of the way as you grind food, right? Especially if you can't sense your tongue very well, then it's going to be a problem, okay? So it manipulates the food and it creates a bolus. So I'll put that it creates a food bolus. And that food bolus is really important because this is what is going to ensure that the food does not go into the respiratory system. So you want to chew your food and then you want to swallow the boluses. You do not want to inhale your food. If you breathe in while you're swallowing, sometimes the food can go down the wrong pipe. So it'll get into the trachea instead of the esophagus. Okay. So if we look at the back of the throat, when you swallow, I'm going to put this underneath. So we have the oral cavity up here. This is the next major division. And this is called the pharynx. And I spelled that wrong. There's an N in there. Pharynx. Okay. So the pharynx is the common opening. This is a Y. This is the common opening to the digestive and respiratory systems. And so remember, as a chordate, the primitive chordate had pharyngeal gill slits. And so this is why we have this common opening because, like, for example, the lancelets and other organisms, they filter food out of the water and then the water goes over their gills. And so the respiratory system and the digestive system were together. So this is why we don't have like a hole in our trachea that would allow us to breathe directly. right? Sometimes they do a tracheotomy where they put a hole in the trachea so that you can bypass the pharynx. So you can take air directly into your trachea, okay? So there is a structure that prevents food from going into the lungs, into the trachea, and this is what is called the epiglottis. So this is a flap that folds over the opening to the trachea. Okay, so this prevents food from getting into the trachea. So epi, it's actually upon the opening, which is actually called the glottis, but the epiglottis is a flap. So this is actually a mechanical valve. So that's why we have to have the food bolus, right? The food bolus actually presses down, or saliva when we swallow helps to press that down so that it closes, okay? So I'm gonna show you just a little video where they took a person that was talking and swallowing. They did an MRI of them so that you could actually see what was going on in the throat region, okay? So if we look at this diagram right here, this is their nasal cavity up here. This is a magnetic resonance imaging. So this is the oral cavity right here. This is my pharynx. This whole thing is your tongue. It's huge, right? It's a big muscle. And then right here is going to be the epiglottis. So see this flap right here? So I want you to pay attention to what is happening when that person swallows. It's also going to show them speaking and how the movement of the air and the tongue manipulate to create sounds. I thought this had a volume. And he's speaking German. So right here is the uvula, right there. So that's that thing that comes down that you can see in the back of your throat. This is the nasal cavity, so stuff drains back. And then this is the epiglottis. So let's see if we can fast forward to where they're swallowing. Oh, I thought he took a drink. Maybe it's at the very beginning. There. So he just swallowed some saliva right there, right? So that flap goes down, and then what happens is that this is the trachea, and then behind the trachea is the epiglottis. Okay. Are there any questions about that idea? So that closes the trachea off. You can feel the trachea, right, in the front because you can feel those cartilaginous rings. And then behind the trachea is the esophagus. Okay. So the next part is the esophagus. So this is a tube that transports food from the pharynx to the stomach. It is lined with epithelial tissue, but it is actually stratified epithelial tissue like our skin, because if you think about it, when you swallow food, it creates friction. And so sometimes when you swallow something, you can feel it. So let's say you swallow a sharp chip and you can feel like a tortilla chip, you can feel it move down through the esophagus. This is also smooth muscle, right? So the smooth muscle is involuntary contractions. So once you have swallowed, you have no control. Those contractions of the esophagus are going to force the food to come back and go down into the stomach. Sometimes if you take like a real sticky vitamin or a pill, sometimes it gets stuck. And you know that sensation of like something being stuck in your esophagus because it feels like the muscles are contracting, but it's stuck to the side and they keep contracting and they can't force it down, right? So that's where you like take a drink of water or you eat something to get the substance to move down, okay? So the esophagus travels through a structure called the diaphragm. And we're going to talk about the diaphragm, that's an AGM, when we get to the respiratory system, because the diaphragm, we mammals are the only organisms that have a diaphragm. So reptiles and amphibians do not have a diaphragm, neither do birds. And so it aids in our breathing. So it actually allows us to get more oxygen because we need more energy because we are endothermic. So that's actually another adaptation to being endothermic, is having that diaphragm. So it is a respiratory muscle that aids in breathing. But the thing about this is that this actually creates a valve. So when it goes through the diaphragm, which is a muscle, it actually helps to prevent gastric juice from getting back up and into your esophagus. So this creates a valve, which prevents what is called acid reflux. That is sometimes called heartburn, right? Because it feels like your heart is burning. Generally that's up high because this is where your diaphragm is, right underneath your ribs. And so your stomach is actually really up high and it's actually to the left side. Down in your belly, near your belly button, those are your intestines. So if you have pain like up under your ribs on the left side, that is actually where your stomach sits, okay? So if this valve does not work properly, and in some people it doesn't, you can get too much acid being come up into your esophagus, and that can actually lead to esophageal cancer. So having chronic acid reflux is really bad because it can damage the lining, which is not protected from the acid, and it can lead to people having cancer and having to have their esophagus removed. So let's look at our diagram here. This first opening right here, and I kind of drew over it in my diagram, but this is my pharynx. This would be my esophagus. Okay. This is where my diaphragm sits. So I'm just going to draw that in there. This is my diaphragm. It's not drawn in there because it technically is not part of the digestive system. Okay. So this is the stomach. So there is a really common thing that happens in people where they get what is called a hiatal hernia. And sometimes this happens in females when they are pregnant. And what this is that the stomach gets forced above the diaphragm. So part of the stomach extends above the diaphragm. And the way you get this diagnosed is that you go to a doctor, a gastroenterologist, and they give you a drug that just makes you not remember, which is kind of a funny drug because it also makes you very talkative. So you're talking blah, 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 and then they give you a camera that goes down your esophagus and into your stomach. So if you have stomach problems, if you have ulcers, or if you have chronic heartburn, that is the way they would diagnose that, to see if your stomach is extending above your diaphragm. So let's see, I have a picture of that. Oh, here it is. So if you typed in hiatal hernia, you might get a diagram that looks like this, right? And so this just shows the stomach, part of the stomach is extending above. So it's herniating, right? We oftentimes think of a hernia as where part of the intestines are extending through the body muscle wall, but in this case, it's above the diaphragm, okay? So oftentimes what they do if you have a hiatal hernia is that they give you acid-reducing drugs. And so that would be like omeprazole. I'm trying to think of the drug names. Does anybody know what a drug name for it is? Can't think of. I know the generic names. Anyway, so acid reducers reduce the amount of acid in the stomach, which can be a bad thing, but it's a good thing if it protects your esophagus. They can also go in here and pull the stomach back and try to anchor it back down. But so through surgery, they can fix hiatal hernias, but sometimes they just reoccur. And so it tends to not be a permanent fix. Okay. Oops, back. Okay. So the next part we're going to talk about is the stomach. So the stomach can actually literally expand, right? So when people talk about, oh, I think my stomach has shrunk, it could be that they're eating really small meals and their stomach has indeed shrunk. But when you eat a large meal, the main function of the stomach is storage. So it stores food and liquid. So in general, it's about 2 liters. So if you think about those 2 large Pepsi bottles, right? That's how much you can generally store in your stomach. So your stomach can expand, right? And so this is actually a good thing because that means that we do not have to constantly eat small meals, right? You could literally eat 1 large meal a day, right? And then you could do other things, if you think about it, that would be useful in a place where maybe food is only available once per day, or if you have other things to do. But this becomes a problem in people that eat too much, right? And so one thing that sometimes people do is that they reduce the storage capacity of their stomach. And how do you think they do that? Right, they can staple it. Right? So they can staple it. They can do a gastric bypass. Right? So they can actually connect the esophagus to a part of the stomach, the low part of the stomach. So they're actually bypassing the main part of the stomach. So they just do a gastric bypass. And then they have a new one, and I can't exactly remember what it is, but it's kind of called a lap band. So this actually is a band that they can adjust. So weirdly, you could have them, if you know that you're going on vacation, you could have them release the band so that you could eat a lot. You're going on a cruise, right? And then when you come home, they tighten it back up again and you can't eat a lot. But the problem with this is that really, if you're going to eat all the time to make up for just not eating big meals, then you're not going to lose weight. But this would prevent you from gorging, from eating a huge meal at one given time. But you can still take in a lot of calories over short periods of time, okay? So this is one function. So stomach, storage of food. The second is mechanical digestion. So we have gastric juice plus food equals a substance called chyme. So this is like a slurry. Like if you mix up the gastric food, or the gastric juice with the food, you produce a substance that is called chyme. And this mechanical digestion is the churning of the stomach. So it mixes the chyme. So it mixes the gastric juice and the food. Okay, it also has protective mechanisms So we have chemical digestion. And the stomach is primarily responsible for protein digestion. And we there's a chemical that's produced by the gastric glands called pepsinogen. And it is converted to an active enzyme called pepsin. So this is inactive, and this is active. Anytime you see the word inogen, like fibrinogen is in your blood and it turns into fibrin, which causes clots. So inogen means inactive. And then you take the inogen off, the OGEN, and then it becomes active, okay? So this is activated by hydrochloric acid. So this is one of the reasons why your stomach is acidic, is that it activates pepsinogen and turns it into pepsin, and this breaks down proteins. And if you remember that maybe from Biology 101, when we talked about proteins, we have amino acids that are linked together by peptide bonds. So this is actually breaking chemical bonds between amino acids, okay? So HCl, which is hydrochloric acid, is extremely strong acid. And so HCl can break down connective tissue. Okay. So let's say that you were going to eat a steak. The steak is high in protein because muscles have lots of protein filaments in them that allow for contraction. And then the muscles are surrounded by connective tissue, right? And so that hydrochloric acid is going to help to break down the connective tissue so that the enzymes can act. It also functions to kill bacteria and fungi. So it is protective. So we're essentially walking around with this big bag, the stomach, full of acid. So if you take acid reducers like I do, because I have a hiatal hernia and I'm worried about my esophagus, right? It's harder for you to digest meat like steak. And you're also more likely to get sick from food poisoning. So like if you go and you travel to Mexico, for example, you might, if you're taking acid reducers, you might get more sick from drinking the water than somebody who has a very acidic stomach, right? So there's some downsides to having lower acidity in the stomach. Okay. The stomach also has mucus, and it's called a mucous membrane. And this mucous membrane protects the stomach from self-digestion. So maybe the stomach from the acid. If that acid gets up in the esophagus, it can break through and it can cause bleeding, right? And if the mucous membrane is damaged, it can also cause bleeding of the stomach. And when we get bleeding in the stomach, it's referred to as a gastric ulcer. So there are some things that you take, that you ingest, that will cause bleeding of your stomach. And can anybody give me an example of something that you might ingest that would cause your stomach to bleed? So specifically, aspirin is a big one. But I think Tylenol might be too. I'm not sure. I'm going to put a question mark. Alcohol. So alcohol on an empty stomach will make your stomach bleed. If you eat it, if you take alcohol with food, it's less likely to do damage because you're kind of mixing it with the food. But also salt. right? So probably the worst thing you can do for your stomach is after a long day of work, go home, pop some aspirin, drink a beer, and eat potato chips. Because all of those three things are going to damage your mucous membrane and lead to bleeding of the stomach. The stomach can actually repair itself pretty well. However, in the past, gastric ulcers, if you went to a doctor and you said, my stomach hurts all the time, and he diagnosed you with gastric ulcers, he would say, okay, well, we're going to put you on a special diet. And so no alcohol, no salt, no aspirin. And we're also going to reduce your stress levels because you're stressed out and that's what's giving you ulcers. So for a long time, people were actually being misdiagnosed because there are bacteria that can survive in the acidic stomach and actually can cause gastric ulcers. And these bacteria are called H. pylori. So that's actually their species name, Helicobacter pylori. So pylori is their species name. Helicobacter, start with the H, is their genus name. And these are acid-resistant bacteria. And they cause ulcers. So if you have ulcers and you go to your doctor, you need to ask him about H. pylori. Because I've known people that have had ulcers for 4 or 5 years. Nothing works. And then they finally ask their doctor about this and he's like, oh yeah. Right? So I think it's more common knowledge, but you can actually do a breath test, right? They can actually do a breath test to determine whether you have H. pylori. And I think they can also do a blood test to determine if you have it.
They do, when I did that, they did a blood test.
A blood test, yes. And so what they're looking for is antibodies that are specific to this bacteria in your system. H. pylori can also be a cause of cardiovascular disease. So it's bad to have in your body because they could cause, problems with your blood vessels as well. But so these can be the source. The problem is that they're really resistant to antibiotics as well. And so you generally have to take antibiotics a long term, 6 months or some horrible thing in order to get rid of the H. pylori. So you don't want it. And supposedly there are some people that have it and it doesn't cause problems, right? So just having H. pylori doesn't mean you need to take antibiotics. It's just if it's causing problems in your stomach, you need to take antibiotics. Okay. So we have a valve between the stomach and the small intestine, and this is called the pyloric valve. Right? And this allows a little bit, I'll just put a little bit, milliliters of chyme to be released into the small intestine. So remember our idea of being compartmentalized. So the small intestine is not acid resistant and it'll actually bleed if too much chyme. Chyme is acidic, right? So it opens up and there's this squirt and another squirt and another squirt, and just a little bit is released into the small intestine. If it opened up big time and all the chyme ran into the small intestine, you would get bleeding in the small intestine, and that would be bad because this is where we absorb nutrients, okay? So let's go back to our diagram. Right here is my pyloric valve. So right there where it gets skinny. Okay. So this part of the small intestine, this is my small intestine. It's kind of confusing because my small intestine is actually longer than my large intestine. So this would also be small intestine down here, right? But it's considered to be small because it has a small diameter, right? So we're going to say this has a small diameter, but it is long. Right? So this would be my large intestine. So my large intestine starts here, and then it goes up, and you got the transverse intestine, and then you have the descending intestine. So all of that is the large intestine. Okay. It is large. It's not long. It's actually shorter than the small intestine, but it has a big diameter, right? And then we have the rectum, where we store feces. And then we have the final valve, which is the anus, which allows us to get rid of our feces. Now, there is a part of our large intestine, which is interesting, and it is called, it's right here, and it is called the cecum. And the cecum in humans is really small, but if you look at the cecum in like rabbits or in horses, it would be very big. So the cecum houses good bacteria. So we have good bacteria that are actually important. One of the things that these bacteria do is they produce a vitamin K, which is necessary for blood clotting. So we have good bacteria. We're going to talk about the microbiome in a minute. But what do you think this finger-like projection coming off of the cecum is called? The appendix. Right? And so the appendix has immune function. So this is the immune system. So if your immune system senses that there's bad bacteria in your digestive tract, it can take measures to destroy those bad bacteria, right? So that's why we do have part of the immune system which is associated with our digestive system, because if we get bad bacteria in there, it can be very detrimental to our health. However, good bacteria are necessary. And if that appendix itself becomes infected, it can sometimes rupture. And so that's what is referred to as, well, not it's rupturing, but we have appendicitis. What does itis mean? Does anybody know? Inflammation, excellent. And I'll just put possible rupture. Right, so if that gets inflamed, it can get big and it can rupture, and it can actually rupture into your body cavity. So we have this huge body cavity in our abdominal region. And if that ruptures, food and bacteria get into the body cavity, and you can die really quickly from just having this massive infection. So if it does rupture, they actually have to open you up and they actually flush out your body cavity. So they like wash it out with water, with saline, and then they give you massive doses of antibiotics to try to fight off any bad infection that might get into the body cavity. So it's really scary when that does rupture because of the possibility of infection. And interestingly, it seems to happen in children more often than it does in adults. So it generally, like my daughter had this, and she did not feel pain. Like they say, it's pain on the right side. She just had a really bad stomach ache. And you take them in and they're like, oh, they just take one look at the kid and they're like, oh, how old is she? 10. Oh, she's in so much pain she can't walk. Oh. And they're like, they essentially can diagnose it just by looking at them, because it's like of that right age, having that massive pain and just a high fever can mean that it had ruptured, right? And then you have to
lift your leg up by any chance to see like if she could lift her leg up.
I actually wasn't there. My husband took her in. But yeah, so I was with my youngest daughter. But did they do that to you? Did you have that?
They were just, I've had stomach problems forever. They can't figure out what exactly it is. And I know that that was one of the methods to see if I did have appendicitis. Apparently, if you can't lift up the leg opposite
On the right, the
appendix,
opposite. Interesting.
if you can't lift it up, then that means that you have appendicitis.
Well, she couldn't walk, so she couldn't walk at all. Unfortunately, I feel like a terrible mother, but I don't generally take my kids to the doctor unless they're really, really sick. And my youngest kid had the flu. And so when my oldest kid started vomiting, I was like, oh, it's just the flu. And so she had it ruptured for a couple of days by the time she had gone in. So she was really, really, really sick from it.
My sister's had theirs on a flush.
On their what?
At 11.
At 11. Seems to be that's around that age. Yep.
Last senior. Junior.
So it could be a little bit older.
Yeah.
Yep. Okay. So let's look at the small intestine. So if you look back up at the small intestine, there is this gland, and it's yellow in my picture, right? There's this gland, and it's right next to the stomach, and it produces insulin. Does anybody remember what gland produces insulin? The pancreas, yes. So this is my pancreas. The pancreas also produces digestive enzymes, which are really important for the functioning of the small intestine. So I think I can just fast forward here. Okay. So the small intestine has chemical digestion. So we have pancreatic enzymes. So these pancreatic enzymes digest almost everything. So they digest lipids, they digest DNA. The DNA that you take in from another organism can be broken down and used to build your own genetic material. And then proteins and carbohydrates. So we have, for example, like lipases. Right? We have pancreatic amylase, which breaks down carbohydrates, just like the salivary amylase. And then we also have nucleases, which break down DNA. And then we have protein digesting enzymes as well. So sometimes when their pancreatic ducts can get blocked, and this actually happens in people that have cystic fibrosis. So not only do they have problems with their lungs, but they get mucus blocking their pancreatic ducts. And so sometimes people have to take in enzymes with their food. And you can actually buy enzymes that you would eat with your food, that pancreatic enzymes, that would help to speed up that chemical digestion in the stomach. Now the question is if they can survive the acidic environment of the stomach. So some of them might be denatured and inactivated, but you can take in enzymes that would help with digestion. And people with cystic fibrosis do that. Okay. We also have mechanical digestion. And this is the one that's everybody gets confused about because it is bile. Bile is a chemical, but it is not technically an enzyme. So we say that bile emulsifies fat. That's an F. So it takes big fat globules, and like a detergent, the detergent you would use to wash your dishes, it turns it into fat droplets. So it mechanically breaks them down like a detergent so that the enzymes have a greater surface area over which to attach to the fat droplets and break them down. So the lipases would then come in and chemically digest your fat so that you can absorb it and use it to produce, like, for example, cholesterol, or to store fat, or maybe even to produce energy. Okay. So where is bile produced? Does anybody know? It's stored in the gallbladder. So bile is produced by the liver. And it's stored in the gallbladder. Now, some people have problems with their gallbladder, and it can be hereditary. So, for example, if this runs in your family, you could get gallstones. So the gallstones are bile, what they call bile salts, plus cholesterol. So you could have a pain, a sharp pain, if one of those gallstones gets stuck in the bile duct and is not able to exit into the small intestine. And that supposedly is really, really painful. And so it can also cause the gallbladder to rupture. So people with gallstones that have them and they're a big problem, they sometimes have their gallbladder removed. And when they have their gallbladder removed, then they have a more difficult time digesting fats. And so if they were to take in the fats, they're not able to digest them and break them down as readily. And so sometimes that leads to diarrhea-like symptoms because the fat just goes right through them and it's not broken down. And so it kind of lubricates the whole digestive tract. And so they have problems with eating lots of fat. So if you have a gallbladder issue, you would want to avoid eating lots of cholesterol, like hamburgers and milkshakes and French fries. If you were to eat that, you would probably feel pretty sick. Okay. So if we go back to our diagram here, sorry, my diagram is way up here. This is the liver. It's huge. Okay. It has many functions, what we're going to talk about. But this is my gallbladder, and it's green. So the bile is produced by the liver, and then it's stored in the gallbladder, and then it's passed into the small intestine, where it helps to emulsify lipids. So the last thing we're going to talk about today is the large intestine. So the large intestine, one of its major functions is the reabsorption of water. So lots of water has been added to your food during digestion. So the pancreas adds water, the stomach adds water, right? When we salivate, we add water. And so we need to reabsorb that water. And if it doesn't get reabsorbed, then you get diarrhea. Oh, and I always never can spell. Is there 2 R's? That's a weird word. I think there's 2 R's to it. Diarrhea. So this can actually cause loss of water and can lead to life-threatening dehydration. So there's some bacterial infections that can cause this life-threatening dehydration. And so some that you might have heard of would be E. coli. So we have E. coli naturally occurring, but some strains can lead to diarrhea. And then they have what?
I had that when I was little. I got it out.
Oh, dear. Yeah. So it's just the bad strain of E. coli, and it leads to diarrhea. Yeah. And then we have what is called C. diff. So I'll just put E. coli, some strains, because not all strains.
Is that a CI or a C?
C. diff. And that stands for C. difficile. So diff stands for difficile. So difficile is a really bad bacteria infection that tends to be very resistant to antibiotics. And it tends to be a big problem in people that are in nursing homes. So does anybody know what is a uncommon or unconventional treatment for having a bad C. diff infection? Nobody knows? You might have heard of it. It is called a fecal transplant. Right? So what they have discovered is that you have a bad C. diff infection, and this could occur in anybody, but generally it's older people. Then you just are dehydrated, you just feel really bad, you have diarrhea all the time, and the antibiotics you take cannot cure you. And so what they've discovered is that you can actually take feces from a healthy individual and transplant it through an enema into a person that is sick. And the fecal transplant has good bacteria, and the good bacteria actually fight off the bad bacteria and they win. And so they take over the intestine and you are cured.
I think that would actually help somebody.
Yeah. And so the crazy thing is that in some places, in some cities, for example, you could go in and instead of giving blood, you can actually give feces, right? And so they have fecal banks now that you can get the feces from. And so what they're trying to do is that grosses everybody out. But if you had this and you were going to die from it, if you had chronic diarrhea, you would be sick. You think a fecal transplant might not be all that bad, right? But they're trying to figure out how to do it through oral. So like, can you give somebody a pill that has the good bacteria, and then the good bacteria get into the large intestine? It's just easier to go through the anus and up into the large intestine that way. Okay, so we have the reabsorption of water, and then we have what is sometimes referred to as the microbiome. So these are the good bacteria. And you might have heard of what these microbiome projects, like the projects where people are sending in cheek cells or saliva samples in order to get their DNA looked at. People are now sending in samples to look at their microbiome. So we actually have companies like uBiome, right, where you can actually send in samples, body samples. You can send in fecal samples. Sometimes it's samples of the skin, right? And they actually send you back information about all of the bacteria and fungi that are in your body, right? So they essentially catalog the bacteria and the fungi in the body. And so if you have chronic digestive problems, you might want to check into this, because when I was looking at it today, this is new. They actually you can sign up for it, and you can get your doctor to prescribe it, right? And so this is just one example of a for-profit company. And so what they want to do is they want to check in and look at all of the microbes. And so you could get the smart gut, right? And perhaps even your, maybe even your insurance would pay for it. Some of the other microbiomes are like $150, right? You could send in and get a kit. And they're also interested in looking at your microbiome before and after you change your diet. because they think that if you didn't eat vegetables, if you weren't much of a vegetable eater, they're interested in getting your microbiome sampled. And then let's say you completely switched your diet. So let's say you went off soda pop and you started eating vegetables. Then they're really interested to see how your microbiome would change over time, right? So this might be, if you have chronic digestive issues, this might be an interesting thing to do for yourself, to just see what kinds of microbes you have. And there's more evidence that this microbiome might be important in the health of your nervous system, might also be important in things like autoimmune diseases and even Alzheimer's. So there's new evidence that maybe Alzheimer's starts in the gut and then travels to the brain. So your diet can really affect your possibility of getting brain disorders and autoimmune disorders, okay? So that's the idea of the microbiome and being able to sample it and screen it. Okay, so I'm actually gonna stop there and we'll watch a little video about the microbiome next week. So did everybody get a copy of the homework? Okay. And everybody has a copy of the handout, the diagrams. So we'll finish the digestive system and then we're going to start respiration and circulation on Monday. And I'll give you back your midterms on Monday as well.